So, hi everyone, welcome to my talk. So, choosing the right messaging platform can be a challenge. So you might be considering alternatives to classics like Kafka and RabbitMQ, right? And this is why I'll offer insights on selecting the appropriate messaging platform and introduce you to an alternative to the well-known Kafka and RabbitMQ. And this alternative is Apache Pulsar. So you can see a QR code and a link on your screen, so feel free to scan this QR code. That's the best way to reach out to me and to get access to also additional resources, for example, case studies or benchmarks or anything. All right, so a few words about me. I work at Stream Native. I'm a developer advocate in Europe. I've been a software engineer for more than 20 years now, mostly using Java and Spring. I've built distributed, scalable, and event-driven systems for several industries, including retail and financial services. I live in Lille, in north of France, and I'm one of the leaders and founders of several developers communities, such as the Java user group of Lille. So for those who don't know Stream Native was founded by the original creators of Apache Pulsar. Stream Native is one of the largest contributors to open source around Pulsar, the core of Pulsar, and the ecosystem around it. And we provide a fully managed Pulsar as a service with enterprise features. So this service can be deployed on either our infrastructure or your infrastructure as well. So what is Apache Pulsar? Apache Pulsar is a cloud-native messaging and data streaming platform. Cloud native means that Pulsar is designed for running in containerized environments and is designed to scale out, to scale horizontally. But this is not only about scalability, but also about elasticity. And elasticity is about adapting to workload changes. And Pulsar is both a messaging and a data streaming platform, as we will see in this presentation. So Pulsar is a messaging and streaming platform, but what is data streaming? Data streaming is a process of transmitting data continuously and in real time from a source to a destination, right? The data is sent in small pieces and is processed or analyzed as received. So streaming works best when this data needs to be processed in the right order. The data, let's say these events, they can be interlinked together, right? This data may be persisted for a long time, but also be transformed, aggregated, or replayed. So you may also need to read millions of records very quickly and perform big catch-up reads. So you need throughput. And streaming platforms can handle a massive amount of data. So these platforms scale out horizontally, right? So what are the use cases? Well, typical use cases include data ingestion. That's the process of collecting and importing data from various sources for storage, processing, and analysis of this data. And other use cases can be about real-time analytics. You will make the right decisions based on fresh data. You won't wait for a batch process to be run tomorrow, right? For example, you can implement a dashboard that is updated in real time, or maybe implement fraud detection as well. So the most common streaming platforms are, for example, Kafka, but I can also mention Amazon Kinesis, and of course, Pulsar is also a streaming platform. Now, let's talk about messaging, because I just told that Pulsar is both a messaging and data streaming platforms, and these are two different things. Sometimes we need to assign time-consuming tasks to a group of workers. So one producer service needs tasks to be performed by a consumer service that is a worker. This task can take some time to process, or the consumer service can be unavailable for a couple of minutes, right? And we don't want these events to impact the producer service. This is why we need decoupling. To do that, you can set up a work queue. So this queue contains messages from the producers, and each of these messages is a task to be performed by consumers. So you don't need to perform this task in a strict order. For example, if the task consists in pushing notifications to Alice and Bob's phones, it doesn't matter if I notice Alice or Bob first, right? I won't break anything. Nothing severe will happen. So a message broker manages this message queue, accepts the producer's messages, and delivers them to the consumers so they can perform the task. So here are some essential features for a message queue. Queues can grow faster than consumers can handle. So one expected feature is the ability to add new consumers to consume the queue faster and remove those consumers when the workload decreases, right? Another expectation is when a consumer is busy processing a message, you don't want to wait for the processing to be completed. The broker will deliver the next task to another consumer instance without waiting for the current task to be completed. When a consumer fails to handle a message because of an error or a timeout, you may need the message broker to redeliver the message later to retry the task, right? And you also need to remove undeliverable messages from the queue and move them to a dead letter queue. And because of that, messages may then be consumed in a slightly different order than produced. But as we said, the order is not a strong requirement here. So RabbitMQ and Amazon SQS match these requirements because they implement this message queue semantic, and we cannot expect these requirements from a streaming platform. These platforms are not designed for that. However, Pulsar implements both the streaming requirements and the message queuing requirements. So data streaming and messaging require a different set of features. For the data streaming, it's about processing the data in order. It's about the ingestion of large amounts of data. It's about data retention because you need to keep the data to, for example, to replay those topics, to replay this event stream, because you need to handle catch-up rates. And Kafka is good at doing that, and Pulsar as well, because these are data streaming platforms. These have all these features. In the message queuing world, you have different requirements. You need to add or remove consumer dynamically to adjust to workload changes. You don't want to block the queue when a consumer is busy or fail to consume one message. You expect to be able to redeliver failed messages later and also be able to schedule or delay message delivery. So RabbitMQ does that pretty well. And what is great with Pulsar is that Pulsar has all of these features. Pulsar implements the features on the left and also the features on the right. So it can process large data streams, just like Kafka, but it also provides message broker features, like RabbitMQ, for example. Okay, so why not use Kafka to implement a message queue? Because Kafka is also about producing and consuming messages, right? So you may think using a streaming platform to implement a work queue is a good idea. However, when I tried to do that, well, that looked a bit like this, right? So let's do that together. Let's implement a message queue using a Kafka topic. So we'll start with something simple, a single consumer, and the topic will be configured with just one partition. Now, let's say that I need to consume the queue faster because the queue is growing too quickly. Then I need to add a new worker, a new consumer to the Kafka consumer group. However, when you need to add a new active consumer to the same consumer group, then you need to add a new partition to the topic. For that, you need to perform an operation on the broker side. Every time you need to add a new active consumer, you have to perform an operation on broker side creating a new partition, and you also perform a rebalance of the data across the newly created partitions. This can be heavy, and this can lead to performance loss or even downtime, and this is why new partitions in Kafka needs to be anticipated and planned carefully. But Pulsar doesn't have this issue. Now, let's take another example. Here, one message always fails when consumed because of an invalid format, for example, or because the consumer is busy processing this message for a long time, right? Then the remaining messages in the queue are not consumed. The queue is blocked. It's normal because there is only one consumer, one worker. Fine, so I need another consumer to consume the remaining messages. But remember, to scale out consumers, I need to add a new partition on the broker side, so I run into the same issue as before. Okay, so let's say that I have my two partitions now and two active consumers. That's great. So is the problem solved? We are about to find out. Let's say that one message blocks the queue again. Then tasks from the partition 1 will be processed, which is better, but partition 0 is still blocked. You have to wait for consumer 0 to finish before processing the remaining tasks in partition 0. So the problem is not really solved here. So I intended to illustrate that using a data streaming platform for message queuing is not ideal. These platforms are not designed for that. This is not the same use case, not the same semantics. Messaging is what message brokers such as RabbitMQ are designed for. So does it mean that you have to choose between messaging and streaming? Or do you have to manage two different platforms, one for messaging and another for data streaming? Well, that's not a dilemma with Pulsar. You can do both using the same platform, the same technology. So with Pulsar, you have only one SDK to learn when you're a developer, and you have only one broker to manage in production. So how is it possible for the same broker to manage both messaging and streaming? There are important concepts to understand here. So let's start with the concepts you can find in most messaging and streaming platforms, right? So you have a producer that sends the data and doesn't know about the consumers or their status. The consumer receives this data from the producer and never directly interacts with the producer because they're the broker in between, and all interaction goes through the broker, here Pulsar, and the broker handles all communication. So the data is sent and stored on topics, and you can find these concepts in most broker technologies. However, Pulsar brings an additional concept. This is the subscription. Pulsar consumers declare how they want to consume messages. For that, they connect to a subscription. The subscription specifies how consumers using the subscription will receive the topics messages. Will they receive the messages like a message queue or using the data streaming semantics? The subscription tracks which messages are consumed in the subscription, and one topic can have several subscriptions at the same time. That's very important to understand. So we achieved a unified messaging and streaming use cases through subscriptions, and a subscription type is a function of the consumer. The consumer have the choice. The producer doesn't need to worry about how the messages are consumed. So these messages in the topic can be consumed in different ways. When you need to process the messages in the right order, you can use what we call an exclusive mode. In this mode, with this exclusive subscription, you have only one consumer at the same time. So Pulsar enforces it. You will get an error if you try to add another consumer to the same subscription. So you will consume the messages in order because you have only one consumer, so you have no reason to not to consume them in the right order. All right, but what if this unique consumer is down? So if you can't afford to wait for this consumer to become available again, not to introduce too much lag, right? Then you can use the failover mode. In that mode, when your consumer is down, then Pulsar will fall back to another one. And Pulsar will deliver the messages to the active consumer. Now you also have the shared mode. So with the shared mode, messages will be delivered to multiple consumers this time. So the subscription will deliver the messages to consumers in a round-robin fashion. If you need to consume messages faster, you just have to add new consumers, and that's it. It's also easy to remove consumers to save resources as well. However, it's important to note that in this mode, messages may be processed in a slightly different order than they were produced. This is why the shared mode is about messaging and not streaming. This mode works best when your consumers are workers that share the same task queue, right? The same task queue, and each message is an independent task to be performed. So when we are talking about these different subscription modes, we talk about how some of them are more useful in messaging domains versus streaming use cases. So failover and exclusive modes are very useful for streaming, and shared is useful for messaging. Now, what if you need to scale your consumers to consume the messages as fast as possible, like the share mode, but you still need to process the messages in the right order, right? You need both. Then you can use the key shared mode. This mode is the same as the shared mode, but with a very important difference. If the messages are produced with a key, then the messages that share the same key will be delivered to the same consumer. So you can process all the messages with the same key in the right order. You can use the subscription mode for both messaging and streaming, but key share mode is great for scaling out consumers like the share mode, but because you have an ordering guarantee by key, then you can scale your streaming processing. You can add or remove consumer without creating new partition, without doing anything on the broker side, right? All of this happens on the consumer side. You just have to add a new pod or remove one, and that's it, without the need of creating new partitions, which is pretty cool. All right, so we just saw that Pulsar can handle both messaging and streaming use cases, and this is one of the key features of Pulsar. Now I want to talk about Pulsar scalability and elasticity. And these are different things. Elasticity means you can grow or shrink resources quickly to adapt to workload changes, so you can save infrastructure costs by avoiding over-provisioning, right? So some data streaming platforms like Kafka and Pulsar can scale very well, but Pulsar is both scalable and elastic as well. So the scalability requirements are determined by the bottleneck you have to address. If your bottleneck is the number of messages remaining to be consumed in a topic, then you need to scale on the consumer side and only on the consumer side. You don't have to do anything on the broker side, right? But when the bottleneck this time is the number of topics or the number of connections with clients, then this time, and only this time, you need to add more processing power to the cluster. And when the bottleneck is the storage capacity, then you need to add more storage capacity to the cluster. Okay, so now let's delve into the first bottleneck, which is likely to be the most common you will encounter. So suppose you have multiple consumers consuming a topic. Then what happens if the number of messages to be consumed grows faster than the consumers can process them? Then, with Pulsar, you just have to add new consumers to what we called a shared or key share subscription. So you can increase the throughput by adding new consumers. And that's it. With Kafka, when you need to add a new active consumer on the same consumer group, then you need to add a new partition to the topic. And remember, you don't need that to scale out Pulsar consumers. All of that while preserving the ordering guarantee, unlike traditional messaging brokers. Now that we delved into the most common bottleneck, let's explore how Pulsar can handle a rapidly increasing number of consumers and producers, a rapidly increasing number of clients. But first, I need to explain the unique architecture of Pulsar. This architecture is more sophisticated than other platforms, so it brings many benefits. In Pulsar, there are two types of nodes, the broker nodes and the bookie nodes, right? The broker nodes are responsible for managing all the communication and the processing of the topics. So they are stateless. They don't store data. So a broker node deletion won't impact the data. In contrast, the bookies nodes are responsible for storage. They have state, right? They store your messages. And the bookies are Apache bookkeeper nodes. So let's say that I need more processing power on my cluster. Then I just had to add more brokers nodes. And because their state is stored in the bookkeeper tier, I can add a new broker, and that load can then be migrated to another broker. And so some of the magic of Pulsar is that it will take care of all the moving of connections. So this event is transparent to your application. If you compare this to Kafka, then adding a new broker with Kafka, I would add to manage the movement of all the data to another broker for it to rebalance it, right? I need to rebalance data with Kafka. But here with Pulsar, there is no heavy partition rebalance, there is no data movement. When you add a new broker, it's instantly available for managing new clients. And when we need to store more data this time, then we'll just add more bookies. And as soon as you add a new bookie, it's going to be eligible for getting new messages right away. It immediately becomes functional. And there is no data rebalance and no data movements, unlike Kafka, right? So Pulsar does not have this issue when you need scalability on your data or elasticity as well. So here is a recap of these three levels of elasticity and the benefits compared to other streaming platforms. When you do data streaming or messaging, your most common bottleneck is the consumer. And the advantage of Pulsar is that scaling consumer doesn't require complex operations like adding partitions or all that stuff. If your bottleneck is the processing power, you just have to add new broker nodes without the need for data movements across nodes. And finally, if storage capacity is the limiting factor, then adding new bookie nodes resolves the issue. And unlike other platforms, these nodes immediately receive new messages. And of course, you can easily downscale to save on infrastructure cost as well. And to ease the use of Pulsar in a Kubernetes environment, we developed Kubernetes operators. So these operators facilitate the deployment of Pulsar cluster on Kubernetes. So you can define your desired cluster configuration using, those familiar Kubernetes YAML files, right? And this allows for seamless scaling, and this facilitates the installation of additional components as well. So you can find the documentation on the StreamNative website. Don't hesitate to check this out. And StreamNative offers these operators under a simple and free-to-use community license. So I just presented how you can scale Pulsar with its multi-layered architecture, which is the second key feature of Pulsar. Now, let's shift our focus to another critical aspect. How does Pulsar safeguard the durability of your data? So Pulsar topics are made of segments. And these segments contain your messages, your events. Pulsar can distribute those segments to separate bookie nodes. And this is how a single topic is distributed across several data nodes, right? And it's important to note that the storage model is completely different from the Kafka storage model. The Kafka storage model is a partition-based model, whereas the Pulsar storage model is a segment-based model, which is quite orthogonal. And here you have a replication factor of 3. So every segment is replicated on 3 different bookies. So if I kill one bookie, the bookie 2, for example, then I still have all the segments in the other bookies, so I haven't lost any data. Now you may need to store a big amount of data and retain it for a long time, right? Depending on your use case. You need to read these old messages that were produced maybe days or months ago. And with Pulsar, you can offload those messages to an external storage. So instead of using our fast and expensive disk in the cluster node, we can rather leverage the use of third-party cloud storage systems, such as Amazon S3 or Google Cloud Storage and such, to move this data into a more cost-effective storage tier, right? And virtually illimited as well. And this is transparent for the consumers. So if you need to replay a topic, then some messages will be read from the cloud storage and others will be read from the Bookies disk, local disk. But the consumer doesn't see this, it's completely transparent. And this offloading is facilitated by this segment-based architecture that I presented. So you can move the old segments and offload them. So this architecture allows older data segments to be offloaded seamlessly. All right, so we've seen what happens when you lose a node, but what if you lose a whole region or a data center, right? And that's where geo-replication steps in. Geo-replication provides disaster recovery. So you have several clusters deployed in different regions or different data centers. And if you lose a region, you can recover from it. Pulsar can replicate the data to different regions automatically in a bi-directional way. And this is built-in feature. So setting this up is basically about configuration. You have nothing else to install, no additional components. It's built-in. Now I'd like to introduce another very cool feature of Pulsar, which is the multi-tenancy. Multi-tenancy allows different departments or teams within an organization to share a Pulsar cluster while keeping their data isolated. So multi-tenancy helps application work in a shared environment by providing structure, security, and resource isolation. The benefits include easier management, as you only need to operate a single cluster or multiple teams. Plus, sharing resources can lead to a significant reduction in the number of nodes in your infrastructure, which can save on cost, right? And this is not a hack or another layer on top of Pulsar. Pulsar is designed for that. This is a built-in feature. Now, you could say, Julien, Pulsar has impressive features, but in my company, I have an existing software ecosystem. I'm sending or consuming messages with Kafka and RabbitMQ. I have a bunch of microservices and I can't rewrite all of them. Well, I have good news for you. Pulsar has a high level of compatibility, and I'll explain that right now. So you remember this, right? The producer, the consumers, and all that stuff. Well, to use the broker, these producers and consumers don't have to use the Pulsar protocol. So you can have producers that are using the Kafka protocol and producing to a Pulsar topic, and you don't have to change the code because Pulsar has a compatibility layer, a protocol adapter that is compatible with Kafka. And that's the same for RabbitMQ and MQTT. And you can do the same with consumers. You can make them believe that they are consuming a Kafka topic or RabbitMQ message queue, but in reality, they are consuming a Pulsar topic. And the magic is that all of that works at the same time with the same topics. So you can integrate Kafka compatible apps with RabbitMQ compatible apps with Pulsar using one single broker involved. To write client application using the Pulsar native protocol and benefit from all features, you have many Pulsar client libraries available, so you will surely find one for your favorite language. That is Java, of course. And don't hesitate to check out hub.streamnative.io, where you will find a wide ecosystem of connectors, libraries, protocol handlers, etc. When it comes to choosing a technology, open source is key, right? Some of the benefits of choosing an open source technology are, for example, sustainability or avoiding vendor locked-in and community support, right? And Pulsar, of course, is open source. All these features are presented are available in open source. So if you download Pulsar, you'll have all of them. You'll get geo-replication, you'll get multi-tenancy, you'll get true elasticity, and so on. And this is great because you don't depend on a specific vendor. You're free to call a vendor to provide the Pulsar as a service, like Stream Native, or you can manage a Pulsar cluster by yourself. There is no vendor lock-in. So a quick history. Pulsar was developed by Yahoo in 2012 as their cloud messaging service. It then went open source in 2016. By 2018, Pulsar had graduated to a top-level Apache project. And since 2019, there's been a surge in the Pulsar community's growth with a rapid adoption and an increasing number of contributors. And it's worth mentioning that Pulsar has been in production for over 10 years now. This means that it's battle-tested technology, it's proven technology, it's robust and mature. Some data on the Pulsar open source community. So there is more than 600 contributors to Pulsar, and there are more making contribution to the ecosystem surrounding around Pulsar. The entire Pulsar code base is growing year over year. And you can discuss with the community on Slack. So the number of Slack members reach 10,000. So many people can help you. And additionally, there are now thousands of organizations using Pulsar. So here is a quick recap. Pulsar is a unified messaging and streaming platform handling both patterns, both semantics at the same time. So you have only one platform to manage. Pulsar is doing great at both scaling and being elastic. It provides true elasticity and 3 levels of elasticity. Pulsar ensures the durability of the data and can offload to external, cheap and unlimited storage. Pulsar has geo-replication built-in, which is great for disaster recovery. Pulsar is natively multi-tenant. Pulsar is compatible with your software ecosystem, and all these great features are available as open source, so you have no vendor locked in. All right, so that's the end of my talk. I hope you enjoyed it. So now feel free to scan this QR code to contact me and to get access to additional resources, for example, comparison between Pulsar and Kafka, or benchmarks or use cases. And I can also share the link on the chat. I will do that. And feel free to try out Pulsar by downloading it, by installing the operators, or by signing up for Native Cloud as well. So any questions? Don't hesitate to use your microphone to unmute. There is a question on the chat. Oh, feedback. Thank you. So I'm going to share the link on the chat. stream. Don't hesitate to ask
I
questions
would
there.
have a question, actually.
Yep, there is a question.
Hi, name is Christian.
Hi.
I wonder if I'm working on Amazon Web Services, and I'm right now evaluating RabbitMQ there.
Mhm.
So I haven't seen Pulsar there. Do you know if they're going to support that too? Or
Uh,
is it there?
your question is, do I know if who will support Pulsar?
Amazon Web Service, because they have Amazon MQ
Mhm.
for RabbitMQ and ActiveMQ, but I haven't seen anything about Pulsar there.
Oh, you mean managed service
Managed, yeah,
from Amazon?
managed.
Oh, okay. Not as I'm aware of, but don't hesitate if you need a managed service to to call Stream Native. We are the main vendor here of Pulsar, but I don't think Amazon has a managed service. Not as I'm aware of. Maybe they have plans, but not as I am aware of.
Mhm. Yeah,
But you
thank
can run Pulsar on Amazon Kubernetes, right? It's not fully managed, but you can run Pulsar on Amazon Kubernetes.
Yeah, I know. Yeah, I'd like to avoid that to run
Okay.
Kubernetes in the cloud. Yeah, actually.
Thank you for the question.
Thank you. Yeah.
Is there statistics of using Pulsar compared to Kafka? Well, Pulsar is used by about 1,000 organizations. That's our estimate here. So Kafka has a larger user base, to be honest. But it depends on what you call using. Is it about the number of users, the number of committers, or Alexandra? Maybe you can unmute if you want to talk.
Kann den
Hi.
Chat nicht richtig sehen. Ah ja, okay, so
Yeah,
jetzt.
I was just wondering, like, Pulsar is pretty much like I hadn't heard of it before, but I heard a lot about Kafka, RabbitMQ. I wonder what is the reason? Is it because let's say, leaked out of Yahoo not so long ago, or what is the reason?
Yeah, I would say that's the main reason because Pulsar becomes an Apache top-level project several years after Kafka. So Kafka is one of the first players in the data streaming world, right? And Yahoo created Pulsar in 2012 because they faced limitations of Kafka at this time. So this is why they created Pulsar. For example, they needed geo-replication and then they needed true elasticity and multi-tenancy. And this is basically why Yahoo created Pulsar. But Pulsar has been open sourced for a few years. I would say 5 or 6 years as an Apache top-level project, right? So it means that Kafka is well known because Kafka joined the community before Pulsar. That's the main reason I would say. And my goal as a developer advocate is to make more people aware of Pulsar because I think it's a great technology.
Okay, and are there any minuses of Pulsar compared to Kafka?
Well, that's a very, very good question. I would say that Pulsar has a sophisticated architecture, right? So it means that if you have basic needs, you may not need Pulsar. It could be overkill, right? But at the same time, if you are, let's say, a big company that has to provide messaging and data streaming services for several parties, such as several departments, then Pulsar is ideal for you because of the multi-tenancy and all those features, right?
Mm-hmm. Okay, yeah, thank you.
Thank you.
I would have another question.
Mhm.
You presented the consumer mode, where the subscription mode is key shared.
Mhm.
And you said that when you use that feature, the message order will be preserved.
Yeah.
What happens in that case when the consumer cannot consume a message? Like you had it in the previous example.
Just going back to our presentation. Yeah. So what happens when?
Nee, hier gerade nicht. Du kannst hier vorbeigehen.
What happens when I assume that you have just one consumer when you do key shared, because basically all the messages sharing the same key will go to the same consumer, right? So
Yeah,
what happens when
you
the
can have
consumer can't consume a message? Is the rest of the messages blocked then, which have
what
the same
happens?
key?
Oh, you see, let's say that one consumer goes down, right? We lose one consumer. That's what you're describing.
No, when the consumer, let's say you had an example where the consumer just takes too long and the message times out, it can't consume it.
Okay. So the consumer takes too
Let's
long
just
or is failing, right? Okay. Then you have two possibilities. It depends on what is most important for you. If the ordering is key, is really what most is the most important for you. If you can't afford to lose the ordering at any moment, then the consumer will be blocked, and at some point, Pulsar will reassign those keys to another consumer. Because, right? But you introduce a small risk of losing the ordering guarantee. And if the ordering guarantee is more important to you than that, then you can there is a setup in Pulsar that I can't remember what name this setup is, but you have a configuration parameter that you can set up to tune this behavior. You can favor the ordering guarantee, or you can favor the lag and the latency, depending on what is most important for you in case of consumer failure.
Mhm.
Did I
And it's
answer
something that can be configured in the subscription? Can the consumer decide what to prefer or what to favor?
If I remember correctly, I think it's a setting on the subscription, but I'm not 100% sure. So don't hesitate to reach out to me using my QR code or using the link that I provided on the chat, and I will be very happy to provide you with the right answer and the precise answer to your question.
Thank you.
Thank you. Oh, there is another question. Could you please tell us more about the elasticity of Bookies scaling out and scaling in? Well, what could I tell more? Could you please tell me what you need? What information do you need? Because I can talk of many things. What I can say is that when you add a new Bookie, then at first the Bookie will be empty, right? So the Bookie will be able to accept new segments, because remember, the topics are made up of segments, which are made up of messages. So a new Bookie, when you add a new Bookie, it will be empty, then it will be immediately available for getting new messages. So the broker will be aware that the new Bookie is available. Then the broker's node will be able to assign the new segments to this new Bookie, right? And at the same time, you can also, if you have enough free space on the Bookies, you can also remove a Bookie. And because of the replication, you won't lose any data as well. So that can be useful for upgrading Bookies, or that can also be useful if you need to remove these Bookies because you have too much, you have allocated too much storage, for example. So you
And
can
will the sec
you can set up retention, so you can reduce the size of the Bookies. Just like Kafka, you can reduce the size of the topics using retention. So it's possible that at some point you may need to have storage that becomes available on the Bookies. Then you can reduce the number of Bookies.
when you add Bookies, when you add one Bookie, will segments be like relocated from other bookies there?
They don't need to. You can, if you are, for example, if you add new bookies to increase the replication factor, then that will happen. But by default, if you add a bookie, it means that you just need more storage. Then there is no data movement when you add a new bookie, unlike Kafka.
Because I wonder if it's a good idea to add just one bookie or always like, let's say 3, because you mentioned that segments are always stored at least on 3 nodes.
Oh, they are stored on 3 nodes in my example because I've set up a replication factor of 3, but I can set up any replication factor that I want. I can set up 1, I can set up to 5 or anything.
Yeah, but to get high availability, probably you will set up at least 3.
Yeah,
No,
I would recommend to set up at a minimum of 3, but you have the choice.
Yeah.
All right, I think I'm afraid it's the end of. I'm afraid we are out of time, right? Yes, I
Thank
think
you.
we are. So, well, don't hesitate to contact me. Right, I will be very happy to answer your the audio or maybe other questions, and also to have more time to dig into details. So thank you.